Well, the topic of our lecture is operations and expressions. Again, let me repeat that on practice you already use these operations and expressions, but during lectures we consider it in great details and we discuss about some very important features of these operations. Maybe these features are not very often used when you write programs, but it's very important to understand these features. That's why today we discuss about operations and expressions. On previous lecture, we consider in details the fundamental data types that we can use in C and C++. Such types as int, float, double, char. We discuss about these data types. And now we will discuss about operations that we can apply to the variables of the corresponding data types. First, very simple operations. Comparison. In mathematics, all the numbers, both real and integer numbers, are ordered. It means that we can compare any two numbers and the result of comparison is defined for any pair. Less than, greater than, less than or equal, and so on. By the way, can you give me an example of numbers that cannot be compared? Do you know such numbers or not?
No, I don't think I know any.
No. Okay, it's a hard question because I think you didn't consider these numbers on algebra or mathematical analysis. I'm talking about complex numbers. Do you know what is a complex number?
Sir, I write the answer in the chat.
Or I don't see the chat. Number I. No. I'm asking about the type of the numbers, like integer, real. All of these numbers, integers and reals, can be compared, but such object as a complex number cannot be compared.
Complex number
cannot be compared. Complex number. But we will consider complex number later, maybe next year, as example. Now we are talking about very simple numbers, real, integer, and all of these numbers can be compared.
What's a complex number?
What is a complex number? It's not a topic of our lecture. Yeah, you can ask the teacher on algebra, or you can type in Google complex number, right? Wikipedia.
Sorry.
And the first link, you can read a lot of information about complex numbers. Complex number is such some generalization of a real number, and we will consider complex numbers as example later, maybe next year. Okay, but the real number and integer number, they can be compared. It means that if we take any two numbers and we apply the operation, the result of this operation is either true or false. So there are only two possible states of the result, true or false. It means that the result is logical, or in other words, Boolean. The logical variables are called Boolean variable in order of George Boole, the English mathematician who invented the special branch of algebra that works with their logical variables. And in C language, we can compare these data as well. The operations, comparison operations, are written here. Less than, greater than, less than or equal, greater than or equal, and not equal. So please remember that comparison operation equal is written as a double equal sign, and not equal exclamation mark and equal sign. Not equal, because there are a lot of mistakes when the students write with one equal sign instead of two. If you write one equal sign, what is the meaning of one equal sign? What is this operation? I think you consider it on practice a lot of times.
That's what you use when you're setting a variable to a value. It's not
Yes.
when you're putting a condition.
Okay, but what is the name of this operation? Short name. It's not comparison operation, but assignment. I assign a value to a variable, but this is comparison. But in clear C language, there is no logical data type. The result of comparison is numeric. Namely, if the condition is false, the result is 0. False considered to be 0. If the condition is true, the result is 1. The result is 1. This remark corresponds to clear C. But when we write in C++, there is a special type that called bool. Again, Boolean variables, the type bool, in order of English mathematician George Boole. And the possible set of values for bool is true and false. And again, maybe it's better to write false and true, because false equals to 0 and true equals to 1.
Sir, Bool, it's like if and else, or no?
Yes, it's very, this operation comparison is very often used in branch. if branch statement, if and else. We consider it next in great details again next week. Of course, on practice you already use it.
Yes.
Well,
Thank you.
bool have two possible values: false that equals to 0 and true that equals to 1. For example, let's consider two variables a and b, and the result a smaller than b. We check this condition. The result is 1 or true. A equals to b. The result is 0 or false. Again, the result of comparison is numeric, but this number can be interpreted as a false for the type bool if it's 0 and true if it's 1. And this number can be used in other operations. Let me show you an example in Visual Studio. Let me open Visual Studio. I create an empty project. Let's write again using namespace std. After that, I can delete cout. I can write handle instead of /n, and of course not hello world, but some, or let's copy these several lines, this line from presentation to program, A and B. Okay, let's output to the screen the result of the operation. A greater than B. Is it true?
No.
Of course, no. So
No.
the result is false. False means 0. And we should see on the screen, let me write here the message, result of comparison we should see 0. Let's check. Or I forget to write space. Yes, you see 0. Result of comparison is 0. If I switch this comparison, for example, into
1.
Yes, right. A smaller or equals B. The result is 1.
Because
The result is 1. We see the integer number, but at the same time, you can use Boolean variables. Let's declare Boolean variable result. I can assign to the Boolean variable the result of logical operation. This is logical, it's comparison. Comparison have a logical result, and the result can have two values, true or false. Again, if I output to the screen the value of the variable result, we will see 0 or false, because on the screen we see the values true or false will be interpreted as a 0 or 1. But in program, I can use these. I can use these identifiers. For example, false. You see that false is a reserved word. It's a key word. It's written in a blue color. It means that you cannot create a variable with the name false or true, but now the value of res equals to false. That means 0. Yeah. And let me write the very simple example with if. I can, if res equals to false, then output this message to the screen. Now we see the message, because in condition I compare res and false. What is the result of this comparison?
0.
No.
1.
1, true. You see, what is the value of variable res?
False.
False. And after that, I check. False. Is it equal to false or not?
Yes.
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 So
False.
it's true.
Yes. False equals to false. And the result of comparison of this comparison is true. 1. False equals to false. True equals to true. Is it clear or not?
Yeah, it's clear.
Yeah.
Yeah.
Result equals to false. If I check here, result equals to true, it will be false, because the value of this variable is false. False. Is it equal to true? No.
Nope.
And we see nothing on the screen. We will not see this message. Okay, and maybe the last feature that I want to show you. This feature is used not very often, but I think you can just as example. C equals to 1 plus A greater than B. The result of comparison of two variables is either 0 or 1. What we will see on the screen now?
1. Because it will be 0 plus 1. 1 plus 0.
1, yes, we will see 1, because the result of this comparison will be 0. If I change the sign to less than, we will see 2. Because the result of this comparison is 2. Okay. Any questions?
No, sir.
No.
No. Well, let's come back to the presentation. Let's move to the next slide. And after that, let's consider some logical operations. Logical operations allows us to combine several comparison operations, or in general, to combine several logical operations using standard operations from Boolean algebra, from logical algebra. These operations are negation, alternation, and conjunction. And these operations denote it's in C language as an exclamation mark, 2 vertical lines for alternation, and 2 ampersand signs for conjunction. Do you know the meaning of these logical operations? Alternation, conjunction?
Yeah, yes, sir. We did this in practice.
Okay, very good. And the result of these operations is also logical. And in any case, if you will have some questions, I will send you additional presentation about logical information. Here you may see the description of these operations. What is, for example, what is X, what is not X, what is A and B, and A or B, A and B, and so on. Well, but if you don't have the questions, I just send you this presentation and we consider this. And we will consider this presentation. The result of logical expression is either true or false, or 0 or 1. Here you may see some example. Let me copy this example in Visual Studio. I can write some logical expression here. For example, if, not if, but result A smaller than B, and B smaller than C. What we see on the screen?
1.
The result, this condition should be enclosed in brackets.
Should be C equals 1, right?
It's better to write result. Result will be 1, true. Okay. If I change the sign here, what we see on the screen?
0.
0.
A smaller than B and B greater than C. This is false. This is true. True, yes. True and false.
False.
False. We see 0. If I change their logical operation to alternation, or
true.
What is
it's true. It'll be 1.
True, because false, true or false is true.
Yes.
We see 1. And of course, these complex expressions can be used very often inside the if statement as the condition. If this condition, that result is true. I can use true here. And we see on the screen 1. Else, let's output false. If this condition is true, we will see 1 on the screen. Let me change there. Or let me write such expression. Not A smaller than B, or B greater than C.
Shouldn't the not be next to the sign?
I think no, it will be false, 0, because A smaller than B, the result is true, but I write here not.
Yes.
Not
False.
not true is false. False or false is false.
Yes.
The result will be false. Let's check it. And we see on the screen 0.
0.
False. Okay. Any questions? I think no. Here you may see there are some examples of logical expression. Okay, let's move to the next slide. And there is some special operation that called operation exclamation mark. And this operation is quite similar to if and else, but it has a different meaning. This operation is written on following way. And the meaning of this operation, the result of this operation is B if A is true and C if A is false. So it's a very, very special type of operation. This operation has 3 parameters, 3 arguments, A, B, and C. A is a condition, and if this condition is true, the result is B. If this condition is false, the result is C. Let me show you in Visual Studio. Again, let's declare the variable result. Result equals to A greater than B, question mark, and A, B. And let's output the value of the result, res. What we see on the screen?
3. Result equals 3, right?
Right. A greater than B is false. So the result equals to the second argument, 3. Right. Result equals to 3. If I change the condition a smaller than b, the result will be 2. Here I can write some complex numerical expression, for example, something like this. And in this case, if it's true, we will see a plus 2, 4. And if I change the condition, the result will be b plus 3. In this case, 6. Well, you can use operation question mark to quickly select between two alternatives. But exactly the same you can do using if statement also. This is just from this point of view, I can say that this is a very short form of if statement, very short and very special form of the if statement.
Is this only in C++?
This operation can be used both in C and C++.
Okay.
Okay, here in this presentation you may find also some examples. I skip it because we consider the same examples in Visual Studio. Well, now here we may see the list of general numeric operations with numeric data. It includes arithmetic operations, shift operations, bitwise logical operations. We don't consider these two types of operations. Maybe if we will have time, we consider it later, because these operations are very special. We consider arithmetic operations, comparison operation, logical operations, and conditional operation question mark. But for correct,
please. What is a arithmetic operation? The first.
Arithmetic operations.
Yeah.
Just addition, subtraction, multiplication.
Ah, okay.
Division. We will consider it on previous lesson.
Okay, thank you.
Plus, minus, star, slash.
Yeah.
But for correct calculation of the expression, of the result of the expression, we will need to define the priorities of these operations. Because of course, in the case when we have just one operation, situation is very simple. We should apply this operation and that's all. But when we have several operations, what will be the priority? Because the result of the operation will depend on the order of operations. On this slide, you will see the list of priorities of all the operations from the highest level up to lowest. First is the highest level. And you see that the highest priority have operation parenthesis when you enclose some operation in parenthesis function call postfix plus plus postfix minus minus. The next level of priority, prefix operation plus plus, prefix operation minus minus, and bitwise operations. Again, we're considered later bitwise negation, and logical negation question exclamation mark. The next level of priority have numeric arithmetic operations, multiplication, division, and remainder. The next level, addition and subtraction. After that, shift operations, we will consider it later. The next level, comparison, this comparison, and logical operations, bitwise operations and logical operations. And the lowest level of priority has their operation question mark. Well, let me show you the example when the priority of operation will have the meaning. So of course, if we apply, if we write some numeric expression like this, a plus b times c, the result of this operation will depend on priority, because the first operation is plus in this expression, but multiplication has highest priority, and the result of this operation, the result of this expression will be 26. But if we change the priority using parentheses, the result in this case will be 48, because we change the priority. Or, of course, 40. 2 plus 3 is 5. 5 times 8 is 40. And the same is true for logical operations. For example, if you write some logical expression like this, a greater than b, or even I can write it without brackets, a greater than b, b smaller than c. We have 3 operations here: comparison, and, or conjunction, and comparison.
It's false.
Right, right. But why it will be false? Because the first operations, according to this, the comparison has highest priority, and in this operation, this comparison will be computed. After that, this one, and we get the result. And only after that,
False and true is false.
Logical AND will be applied.
Yes.
Logical AND will be applied. Here, because here the result will depend on priority of logical operations. Okay. Now let's discuss about comparison of symbols. I show you on previous lesson that there is a special symbol, special data type, char. The values of this data type corresponds to symbols. But how to compare two symbols? The situation is very simple. Each symbol has its own code. All the symbols are numbered from 0 to 255. And we compare symbols using their codes, the corresponding number. The symbol A is greater than symbol B if the code of the symbol in the code table is greater. And the result is also numeric or logical. Well, we can compare symbols. For example, I can write P smaller than Q, and the result of this operation will be 1, because in the code table corresponds to the alphabet, English alphabet, and Q follows after P, and it has a greater code. If I write, for example, P smaller than A, in this case, the result will be 0, false, because A is the first symbol. But also I can compare any other symbols. For example, 1 and A. I don't know the result because I don't remember exactly where in the code table are written numbers and symbols. Maybe I guess that the result should be true, because first it's written symbols, sorry, numbers, and after that symbols. Yes, the result is true. But if you change the sign and compare 1 and A, the result will be false. So here I just want to show you that all the symbols are also comparable. You can compare any pair of any two symbols. But when we write a string, a set of symbols, it's very hard to decide what string is greater. We discuss about comparison of strings later, because to compare two strings, we will use in clear C. We should use a special function like string compare, or in C++ we can use a special data type, a class string. We will discuss about comparison of string later because it's rather complex. Do you have any questions about comparison?
No, sir.
No. Okay, very good. And let's move to the next slide. And let's discuss about assignment operation. From the first point of view, this operation is very, very simple. You have used it many times in your program, and it's used very, very often. You take the expression from the right-hand side of this operation, and the result of this operation is assigned to the variable that is written in the left-hand side. It's also called a simple assignment operation. Sorry, simple assignment. This is an example of simple assignment operation. We already use it in Visual Studio. Something like this: A, B, and C, and we assign the result to the variable res. But as you see, we can assign the result not to the new variable, but to the same variable that we already use in the right-hand side of this of the expression. C equals to C plus A times B. In this case, the variable C is used in both parts of the operation, but in the right-hand side, its value equals to 4, the value before the operation, and in the left-hand side, so it should be left, of course, left-hand side, it equals to 10, value after the operation. Here, the previous value is used, and after the operation, C will be equal to 10. Or of course, 14, not 10. Or A times B plus C. And here I write A plus B times C. Well, I think it's also rather simple, but please remember that the old value of the variable will be lost after assignment. If you will need it later in your program, you should store it. You should store the old value in another variable before assignment. For example, you can declare the old C and store the value here, and after that you will have a new value of the variable C. The old value, this one, will be lost. Okay, the next important feature of assignment is a question of a data type. In this example that I show you, I assign the variables and the values of the saved data type int to int. But what happens if the data types in the right-hand side and in the left-hand side will be different? It depends on the range of representation of numbers. For example, if you assign the integer number to the real data type, it will be okay. For example, let's declare here the same variable res, but for example of the type float. And let's assign res this value. Res equals to res. Here you will have integer type, and here float type, real type. If you compile the program, compiler outputs you no mistakes, but compiler outputs you a warning: conversion from float to int, from int to float. So compiler warns you that you assign the data of different types. Maybe it will be a mistake. It's not a mistake, it's not an error, but maybe. And vice versa. For example, if you take the variable a and try to assign to a the real value, what we will see on the screen in this case? What will be the value of the variable a?
1. Wait, yeah, 1. You just remove the 0.2.
If you compile this program, compiler also outputs you warning that you assign the data of different types, real and integer. But in this case, you will lose this information, the digits after decimal point. The value of a will be 1. Well, when you assign from a smaller type to more powerful type, from short range to wide range, it's okay. But vice versa, if you assign, for example, float to integer, it may have problems. Well, the next feature of assignment operation is a so-called multiply assignment. You can write a lot of assignments in one expression, and in this case, the result of this expression will be assigned from right to left to the variable number n, number n-1, and so on, and variable number 2, variable number 1. So this one operation allows us to assign one value to several variables, like this. So A equals to B equals to C equals to 2 plus 2. In this case, new values of the variables A, B, and C will be 4. It's called multiply assignment. And from the formal point of view, I can consider assignment operation like, for example, addition. A plus B, it has a result. A equals to B, it also has a result. And the result of this operation will be the new value of the variable A. From this point of view, we consider this operation C equals to 2 plus 2. It has a result, new value of the variable C, and this result is assigned to B, and this result is assigned to A, and so on. Okay. And now the next feature of assignment is a so-called modified assignment operation. Besides the simple assignment, we can apply some modification. Well, I show you this slide, and after that I come back to this. This expression, when we assign something to the variable name v after applying some operation, name v, some operation, and expression, is used very often. And for such operation in C, C++ is used a short form of this operation. Name v, the sign of operation, the equals sign, and expression. The meaning of this operation is this. And this is a sign of any operation, any arithmetic operation, plus, minus, star, slash. You can use any operation. For example, plus equals. It means that if you write name v plus equals expression, it corresponds to name v equals to name v plus expression. Minus equals corresponds to name v minus expression, and so on. If you write a plus equals b, what we will see on the screen?
5.
Yes, 5. This operation, the result of this operation is 5. Minus what we will see on the screen?
-1.
-1. Right, because this operation corresponds to a equals to a minus b, and so on. You can use any kind of operation. By the way, very hard question. What we will see on the screen now? A divide equals B. What we will see on the screen?
0. 0.6. Oh no, it's integer, so 0.
0.
Yeah.
Yes,
Yes.
yes. It's a question. You should remember that if the variables are integers, the division is integer too. And 2/3 integer part is 0. And we see on the screen 0. But if I use here float or double, we will see on the screen real result 0.66666, 2/3. Well, this is a short form of this operation, and this special assignment is used very often. Okay. And maybe one of the last features that I want to say. One assignment is used very often, but sometimes you can write very complex expression like this, and this expression is also correct from the point of view of C language. What happens in this case? In this case, first, the operation b plus equals 4 will be executed. And what will be the new value of b now, after this operation?
4.
4? Why 4? 7.
7. Yeah.
7, of course, because the initial value of b is 3. 3 plus 4 is 7. And this new value of b, 7, will be used in the operation a divide equals. So a will be equal to 2/7. These operations are carried out from right to left. New value of b will be 7 and a will be 2/7. But of course, these you can write such expression, but it's very hard to read, very hard to understand, and it's most convenient to write these two expressions in separate lines, like b plus equals 4 and a divide equals b. The result will be the same, but the program becomes more readable, more understandable. Well, this is an example of modified assignment. We already consider these examples in Visual Studio. In some special cases, we can use a special operation, comma, to construct composed assignment. Like this, when you declare some variables, you will use comma to separate the assignment operations. And from the compiler point of view, it's also assignment, but called composed assignment. All these operations are computed successfully from left to right when you write several assignments using comma. And I think the last feature for today. Sorry. I want to discuss about the difference between expression and statement. The difference between statements and expressions consists in the following: that the statement is a complete sentence of the language, but the expression is not complete. When you write something without semicolon, it's considered like expression, and this expression can be used as a part of another complex, another expression. But when you write a semicolon at the end of the expression, this expression becomes a statement. Statement is usually is a separate line of your program. So every line, usually, as a rule, will correspond to one statement, and the semicolon in the end corresponds to the statement. Generally, all the statements may be divided into header statements, declarative statements, and computational statements. In our program, we will use declarative and computational statements. Header statements we will consider later when we discuss about the functions. Declarative statements describe information objects of the program. This is a declarative statement. The semicolon ends this statement. And computational statement. This is a computational statement. The computational statement inside the program can be classified as a simple, composed, and complex statements. Well, the simple statement. Here we see some example of simple statements. It's just modification of some variable using plus plus or minus minus, or there maybe the most known simple statement is the assignment statement, when you change the value of the variable using assignment operation. Well, from the point of view of the language, this is a simple statement. Composed statement is a sequence of one or more statements following one after another that are enclosed in braces. So this is a sequence of simple statements, and all these statements are enclosed in braces. This is a one composed statement. From this point of view, I can say that the body of the main function, so all of the main function, can be considered as the one composed statement. This is beginning of the statement, this is the end. And also, I can write a composed statement at any place of the program. So, in this case, in this example, these braces means nothing. The result of the program will be the same, but this program is correct from the point of view of compiler. I can write here any number of braces, even like this. It's also be correct. It's just empty composed statement. This is also composed statement. Write just a semicolon, it will be considered as an empty simple statement. Of course, it's a very strange example, but it's also correct from the point of view of compiler. If you compile your program, you will see no errors, no warnings. This is a correct construction. Empty composed statement and empty simple statement inside it. So you can write any number of semicolons here. Of course, it seems strange, but it's correct. And also, of course, it's never used, but compiler allows us to write such construction. Okay. And when we include one statement into another statement as internal part, this statement is called complex. Complex statements is used very often when you write if or loop or something like this. Well, that's all for today. Next week, we will discuss about conditional statement, if, switch. Maybe we will start to consider loops. But again, I repeat that you already use it on practice. But here on lectures, we will discuss about it in detail. So we will consider some features of these statements. These features maybe you will never use it, but it's very important to understand, to know these features of these statements. Okay. Do you have any questions?
No, sir.
No.
No
Sir.
questions. Well, if you will have no questions, that's all for today. I stop